Let us discuss one more category of reaction that is called as simple displacement reaction. Even sometimes this is also known as displacement reaction. What is basically your simple displacement reaction? So it's a reaction in which either a single atom or it will be a group of atoms which displaces another atom or group of atom from its aqueous solution. This is most important. The another atom or group of atom get displaced from its aqueous solution. That is called as your displacement reaction. So let me have one simple example here. AB, I took it as an aqueous solution. I react with C. So as a product, I'll get AC plus B. I'll get AC plus B. So I considered here C is more reactive than B, displaces B from its aqueous solution. So let me have one illustrative example to demonstrate this reaction. I have Fe as a solid reacted with aqueous solution of copper sulfate, reacted with aqueous solution of copper sulfate. So we know that copper sulfate is blue in color. Copper sulfate is blue in color. So iron, which is more reactive, so iron is more reactive than copper. Iron is more reactive than copper. So what iron does? Iron displaces copper from its aqueous solution. So I'll be getting here FeSO4 aqueous plus copper metal as a solid. So there will be pinkish deposition of copper is seen on iron. Okay, and the solution will turn light green in color. Solution will turn light green in color. So this is a simple example to understand displacement reaction. Now, generally displacement reaction is based on the reaction of metal with either water or acid, either water or acid. So we have a reaction of sodium metal with water. So what will happen? Sodium metal displaces hydrogen from water, get converted into sodium hydroxide and evolves hydrogen gas So I have to balance this particular, I'll multiply by 2. So this is a simple displacement reaction where metal is displacing hydrogen from water. Let me have one more example here. I have zinc metal reacted with dilute hydrochloric acid. So zinc is placed above hydrogen in activity series. Zinc is placed above hydrogen in activity series, displaces hydrogen from its solution, that is hydrochloric acid. So I'll be getting ZnCl2 plus H2. So zinc is displacing hydrogen from acid. Now generally whenever we try to work out this reaction, we either employ dilute hydrochloric acid or dilute sulfuric acid or dilute sulfuric acid. Nitric acid is generally avoided. Nitric acid is generally avoided because nitric acid, it acts as oxidizing agent. Nitric acid will act as oxidizing agent. So what it does? As an oxidizing agent, what are the hydrogen released? That hydrogen gets converted into water. So I have a reaction of zinc metal with dilute HNO3. So I have zinc metal reacted with dilute HNO3. So it gives me ZnNO3 twice plus colorless nitric oxide gas plus water. So to balance this, I'll take here 3Zn, 8HNO3. So I got 3 ZnNO3 twice plus 2NO, and there are 8 hydrogen atoms. I'll multiply this by 4. So this is your dilute HNO3. Now, if you look at the above reaction, I have zinc was reacted with dilute HCl. I got ZnCl2 plus H2. But whereas same zinc metal, when reacted with dilute HNO3, I don't get hydrogen. I get water as a product. That's why we generally do not employ nitric acid to study this reaction. Now, another important category, like an element which is placed above hydrogen in activity series, displaces element below from its aqueous solution. So I have a zinc metal when reacted with copper sulfate solution, which is blue in color. So zinc is placed well above hydrogen. Zinc is placed, well above copper. So zinc displaces copper from copper sulfate solution. So I'll be getting ZnSO4 aqueous solution plus copper as a solid, and this solution will turn colorless. This solution will turn colorless. So there is an observation here. When zinc metal is placed in blue color copper sulfate solution, the blue color copper sulfate solution turns into colorless, or the blue color of the solution fades away. So this is a reaction where zinc is placed above copper in activity series, displaces copper from its aqueous solution. Thank you.